So this is in continuation to the last two sessions that we had done on artificial intelligence. Today it's going to be, we will be understanding what large language models are. I will not be giving too much of technical, I will be not getting into too much of the technicalities of it. However, am I audible? Uh,
Yes, you are.
okay, okay. Sorry, I thought I was not audible. So we'll be talking about large language models, and these large language models, whatever we'll be talking about, will be from the point of view of user perspective, how we as common computer users can use it. I will give you a perspective based on that. Now, why do I have chosen this particular aspect is because rather than being more technically oriented towards large language model, somebody who is a user should get benefited most out of it. So that's the sole purpose of why I took this approach. However, there will be a small little introduction to the technicality of large language model in these slides, which once we go through these slides, you'll understand. So let's get into what is large language models. Before getting into what actually large language models are, let's get into what are the applications of large language models. Now, when we talk about the applications of large language models, since you have seen ChatGPT and there are many other like Llama, then you have something called DeepSeek. Now these are all one of the magical things about these is that they can understand natural language. So now when we say natural language, it understands human language. So we talk in English to it, it understands that, it understands not only the language, not only the words, but it understands the context of it, which is very important. So since they are able to understand the natural language, their applications is they are used as advanced chatbots, which are capable of engaging in natural conversations. A best example is there for banking applications you might have seen. Now, using these large language models, one of the other applications that we can actually do is we can create if we can create our own personal assistants. For example, I want to have a personal assistant on my own laptop. So I can utilize these large language models. I can download one large language model on my laptop and I can use it for all the tasks like scheduling, keeping the reminders and information retrieval. Another aspect of these large language models is content generation. So since they can understand language, now when we say we want a particular content, a creative content on a particular topic, and we give that to these large language models, they are actually able to give us the content back. For example, if we want them to tell us a story, they can write a story for us. If we want to tell them that write a poetry, they can write a poetry for us. Now, these kind of tasks actually takes a lot of time for, in some cases, some writers are there who might take months to write a particular book, but using these large language models, if we know how to use these large language models efficiently, we will be able to produce this particular book within days. These are so powerful tools. Not only that, they have also started writing codes. In fact, initially they started off with code snippets, but slowly as they are evolving, they are writing codes. These codes not only are in human language, but they are they are writing it in C, C++, Java, .NET. You tell the language and they write the code. And in fact, not only they write the code, but they will write the comments. They will write the different descriptions that is needed for that particular code, the way we humans generally do it. Language translation. Since language, they understand the language, they are able to understand language of different regions of the world, different countries. They are able to translate between the different languages as well. This actually helps in interacting more with the system. Now, there are instances where some systems are there in Korean language, some systems are there in Japanese language, some systems are there in Italian, and then they need to interact with other systems which is in English. It is filling that particular gap of the translators. So it is basically a boon for those kind of developers or users who were stuck because of this language uh, gap. But now, since LLMs are there in the picture, they are actually doing very well in their jobs now. Text summarization. We might have some text and then we might need to get the text, maybe hundreds and hundreds of pages. Now we don't have time to read that particular text. So what we need to do is we need to get a summary of what is that particular text or article. So what can be done is we give the entire text to this large language model, and then it's going to summarize it for us, and it's going to give us the particular notes, the most important notes, what it finds out from that particular large article that we had given. In some cases, what has been done is people have given PDFs, research PDFs to it, and then it has given insights into those research, and then they have summarized it and given it in very less time. So this is actually very helpful for students and researchers. One challenging task where generally most of the computer scientists had been struggling for some time now was sentiment analysis. With the advent of AI, this particular gap has also been filled. Now, sentiment analysis is we give a particular text to the computer or the machine, and then we want to understand what kind of a sentiment does that particular text that has been shared with it convey. What kind of a mood the user is in while he's writing that particular text. So it analyzes it, and then it gives a response like it's a positive content or it's a negative content or it's a neutral content. So this kind of sentiment analysis is actually used in social media posts and reviews and comments. This is very important for retail industry or any online industry, because many of us have already taken our decisions after going through the reviews and comments of a particular product. So this sentiment analysis actually does an analysis of the different reviews that has been provided for that particular product, and based on that it gives the rating of that particular product. So let's get into the use cases as those are the applications. Now, when we say about applications, those applications are small little use cases that we have talked about. We can talk about very large applications also, very large use cases also, or small little use cases also. When we say we simply should not talk about having personal assistant. We can go ahead and then start creating personal assistant for a particular department, or we can take up at the organization level what it can do. So based on whatever data is available with us or with an organization or with a department, there are many use cases that can be taken up. So in this scenario, we are talking about code generation. So LLMs can generate accurate code based on user instructions for specific tasks. This is very helpful for developers because developers, they face lot of challenge in writing codes for UI, or in writing codes for backend, or in writing codes for, or while debugging. So while debugging, what it can do is you can, wherever the code that you're having a problem, you simply take that code, feed it to the LLM, and then ask the LLM to optimize the code and find out if this particular code has an error or not. And it actually goes through that code and then it reverts back to you saying that this particular code can be optimized this way, and then this is the output that it has found out, and it also identifies that particular line, that this particular line or this particular snippet of code is causing the problem. So it is helping the software engineers a lot. Debugging and documentation. As I said previously, that it simply, not only it creates the code, but it identifies the code errors also, and then it fixes that also, and then it provides documentation also to the code that we have written, the way the humans do it. Another use case is question answering. So this question answering is nothing but just like ChatGPT, but ChatGPT, or we have the chatbots which are running in the banking institutions or some other institutions. Here, the large language models, when we talk about the large language models use cases, question answering, it actually talks about, we ask them a question and then it gives us an answer. So these can be with respect to anything. You talk about a political question, you give it a you give it a literature question, or you give it a historical question, or you give it a technical question, you give it a mathematical question, you give it a physical question. So it can take the question and then it's going to give us the answer. Language translation and correction. So it's right now it supports around 50 languages, and whatever languages it is supporting, if it finds some grammatical errors, it can tell us that these are the grammatical errors that has been found in those languages. Now, this particular part is very important. So I want everyone to note this particular thing. Prompt-based versatility. How the users can actually utilize large language models is through a technique called prompting. So anybody who is good at language, who can give the best prompt to the large language model, he will be receiving the best response from it. So when I say your prompts should be the most creative to get the most creative output from the language model. Uh, LLMs have got excellent, they excel in one-shot and zero-shot learning scenarios. So what is one-shot and zero-shot learning scenarios is, like these LLMs have been trained. They have been trained on data, and this training of these LLMs have been happening for years. And in fact, there are scenarios where they have been trained on on I mean petabytes of data, and petabytes of data is huge. Huge means it's huge. Just to give you an example, 1 GB of text input is might be equivalent to around 200 million words. I'm talking about 1 GB of text input, and 1 terabyte of data is almost 1 million GB. And when we talk about petabytes, it's 1 million terabytes that goes into 1 petabyte. So these large language models, and that is the reason it is known as large language models. So when we say it's zero shot learning scenarios, these have been where if you give a particular input to that, let us say if we want to find out, we give an image to the large language model and it immediately identifies that image as a cat or a dog. So this is zero shot because it did not need to learn anything from this particular ex exercise we did. We simply gave it the image, it returned us the response. In some scenarios, what it might do is it might not have been trained on that particular scenario. So in that case, if we give it an input, it takes some time and then it gives us a response. It's able to identify based on the data, whatever has been fed to it over the years and gives us a response back. So that might be a little bit different from what actually exists, but over the time, when we keep prompting it with this kind of a prompt, it gives us better responses over time. So prompt engineering is the one that is going to help you derive the most from large language models. So the use cases of these LLMs are not limited to whatever we have said so far. You just need to be creative enough to write better prompts. That is what I was trying to explain. And if you are good at writing prompts, you can do a variety of tasks. Now the next thing, that is how to get the best out of large language models, is prompt engineering. This is totally new and it's very hot in the market nowadays. I will be doing another session on prompt engineering, wherein I will tell you how many different types of prompt we can send to the LLM models and which is the best out of that, so that we can get the best from the LLMs. As I said, uh, these are the advantages of language models. They can perform zero-shot learning, meaning they can generalize to tasks for which they were not explicitly trained. And this capability allows for adaptability to new applications and scenarios without additional training. And the other advantage, as we said, is they can efficiently handle vast amounts of data and thus they are suitable for the tasks that require deep understanding of extensive text corpora, such as language translation and document summarization. Uh, LLMs can be fine-tuned on specific data sets or domains. When I was talking about the applications of LLMs, not to be specific to one particular task, like it should not be specific to my personal, uh, my personal assistant. It can be used as a personal assistant for someone else, or it can be used as a particular model to be trained on a specific task. So for that particular purpose, we generally fine tune it. Just to give you an example, let us say we have one LLM model. This LLM model needs to be trained on in the medical field, wherein it will be able to identify any X-ray that is fed into it, any X-ray information. We take a scan, we scan the X-ray and send it to that particular LLM. It should be able to identify, okay, what is the problem in that with that particular patient. So this is one use case. In another use case, what we can do is we can utilize a LLM model wherein, let us say, the X-ray which is used in the airports, wherein our baggage is X-rayed, those kind of feeds are put to the LLM and then it gives a output. So even though we are giving the same kind of input to both of them, but each of the LLM has been fine-tuned in such a way that they are going to give response based on the use case that they have been used for. Next is using an LLMs, you can enable automation of various language related tasks from code generation to content creation, freeing up human resources for more strategic and complex aspects of a subject. When we say enable the automation of various language related tasks, let me give you an example. I think many of us are content creators here. So when we say content creators, what we generally do is we have to take a particular subject. Then on that subject, we need to do our research. Based on that research, if we want to add some videos or audios or images to that particular topic that we have created, so that we can combine these together and then create a particular video and upload it to the different social media platforms. Now, this becomes a process which has got certain steps. Step 1, step 2, step 3, and step 4. Now, what these LLMs can help is they can enable automate all these tasks in a particular pipeline. One LLM can be used wherein you give the prompt, it generates the text. Another LLM can be used wherein we give the prompt based on that context of the text that we are generating, we tell it to create images. And the third LLM, it might create a video. And the fourth LLM, we can prompt it in such a way that it's going to put all these content whatever has been created in a particular well documented, uh, we can say a movie or short, and then once it is ready, it should be published to the website, or it should be sent to my email so that I review it before publishing to the website. So this is what it is saying, that LLMs can enable the automation of various language related tasks as well. I want to show you the power of prompting here. So this is a particular image that is, it's a video actually. It's a video which is there in Sora. So the prompt is, it's a storyboard related prompt wherein it has they have given this, a group of 6 workers dressed in dark, worn clothing and carrying tools and backpacks are seen slowly walking on a desolate fog covered beach. So if we go to Sora, I think we can see this. Sorry, let me open this. Sora.ai. No, I think OpenAI.ai. I think, okay. Here, if we go to Sora, I think last time I had given the same example about prompt engineering. So now this is the one. So you see, we have given a prompt of this size, and this particular prompt, it is so descriptive in nature that based on this description, it has created this particular shot. So prompt engineering is so powerful and it is so good that it is the tool that is going to help you interact with the LLM and get the best out of it. Another one with respect to the same prompt engineering that I have included is from the same Sora application or Sora website is this. So let's see what this is. So this one. And here it is. So it's a small little prompt that has been given in such a way that it has created the shot behind. And the best part is this is all generated by AI. Similarly, we have this is a blend video. When we say about blend video, the capability of this particular LLM is that it has taken two videos and it has blended it so perfectly that we cannot make out that it has been blended. It seems as though it is real. Now let's come into the definition of what large language models is. So basically, large language models are nothing but it's a subset of something called a foundation model. So you see this green part, this green area is something called as the foundation model. Now what happens is an initial model is taken and then we have we keep feeding data to it. When we keep feeding data to it, the data can be any form, any format. So it is basically unlabeled data that is fed to a pre-trained model. Now, we had talked once that there are two different ways of training AI. One is supervised learning and unsupervised learning. So in supervised learning, what we generally do is to create, to train a model, we give data which is labeled to it. And once we give data that is labeled to it, for example, if we to how to train a particular model is we need to if we want to train a particular model on images. So let's take the example of a cat. So we take the image of different images of cat, black cat, brown cat, or some cat with patches, Siamese cat, and then we label them. We label them. The label will be like it has eyes, it has whiskers, it has fur, it has four paws, and then it's a small creature. So these kind of labels we put on each of those particular images. And there are specific labels for a specific cat as well, like Siamese cat or Phoenix cat. Phoenix cat, as you all know, this Phoenix cat doesn't have any fur in its body. So that becomes specific to that particular cat. Then Siamese cat, it has a specific color to it. It's got grayish and black and light grayish fur on its body. Then we have Siberian cats. So you label them specifically and then push this data to the LLM. So that becomes supervised learning. Once it starts, it gets the process of learning, then we put it into the mode of unsupervised learning. In case of unsupervised learning, once it understands how to inference the pattern which is present in the data that had been provided to it while it was in the supervised learning phase, it the next phase when it is into unsupervised learning, whatever input we give it, it identifies those patterns and then it starts learning. And then it starts producing generalizable and adaptable output. So if now the example wherein we were feeding the images of cats to the particular foundation model, next time if we are going to give it an image of a tiger, it is certainly going to come out and then say, this is not a cat, this is a tiger. Now, so that is the foundation model. Large language model is nothing but it's a subset of this particular foundation model that had been created. It's a subset. So why it's called a subset is it might have happened that the foundation model had been created with image data, video data, audio data, text data, binary data, or any other different kinds of data. Out of that, we are actually removing a subset of it, and we are using text to, we are giving specific text to make it, to make it a language model. So general model is foundation model. When we are taking an instance out of it and we are giving text input for use, that is when it becomes a language model. Now, why do we call it large? We call it large because, as we said, it is fed with large amount of data, and it is trained on, I mean, 500 petabytes, 1000 petabytes of data. And since this has been trained, the size of this particular model that is getting generated because of the way it has got trained itself runs into gigabytes. So it might be the minimum LLM that we have, the smallest LLM that we have might have a size of, let's say 5 GB, 6 GB, 7 GB. And that is kind of, that might be having a 7 to 8 billion parameters size. And there are large language models now existing which are of 500 GB size. So they are so large, and they go into trillions of parameters, 1.2 trillions or 1.3 trillions parameters. So basically, large language models are nothing but it's a combination of the data, the architecture, and the training that has been given. So all these three things actually make a particular LLM. So the data that is fed, and let's get into what is architecture and what is training. Let's take the example of how LLMs work. When I give it a particular text, it it needs to identify the context, and then based on that context, it should give me some response back. So let us say I tell it, please explain me about the sky. So whatever data it has got, based on that, it starts it starts with some words, and then let us say it starts with the sky. After that, there are n number of that words that can fit in, like the sky is, the sky has. Then the sky is, once it chooses is, it can set it can choose words like big or blue. So the sky is, it chooses, and then it's predicting the next word. So the next word, whatever it predicts, it has a large subset from which it needs to choose. So it might happen that it first starts with the sky is, and then it starts with big, but then it finds out that this particular context might not fit our case. So it will again go into another iteration, and then it will choose another word that fits my requirement of the output. So this predictive word that is happening, this happens in a particular component called transformer. So in the chat GPT, the word GPT actually means generative pre-trained transformer. So it's generating the next word, and it has been pre-trained, and it is a transformer. So to create a particular output for us, it actually has a very big set of words through which it has to find what words are best to give me a response for my context of the query that I have made. And since it is doing an n number of iterations on such a huge data set, it generally takes some time for these large language models to respond as well. So I hope till here it is understood. That's all from my end. Thank you all. Jazakallahu khair.
Thank you.